Welcome to DRX Learning Hub, your trusted platform for Bachelor of Pharmacy first-year lectures. Today, we are going to dive into the topic of non-aqueous titration. Non-aqueous titration is an important analytical method used to determine the strength and purity of weakly acidic or weakly basic drugs that cannot be titrated accurately in water. So, why do we need this method? Well, it's because some drugs are poorly soluble in water, some are very weak acids or bases, and others undergo hydrolysis in water. Therefore, we use non-aqueous solvents instead of water. Non-aqueous titration is a type of titration carried out in organic solvents instead of water. It's used especially to determine the potency of weakly acidic or weakly basic drugs. The principle is based on the acid-base reaction in a suitable non-aqueous solvent. Non-aqueous solvents increase the strength of weak acids or bases, and they improve the solubility of poorly soluble drugs. This, in turn, results in sharp endpoints and, more accurate titrations. Alright, so let's talk about the classification of non-aqueous solvents, starting with protophilic solvents, which are also known as basic solvents. These are the ones that actually accept protons, or hydrogen ions, H+. Some common examples include pyridine, liquid ammonia, and amelamine. And, these solvents are typically used to titrate weak acids. Moving on, the next type is protogenic solvents, which are basically acidic solvents. These are the ones that donate protons, or H+ ions. Examples here would be formic acid and sulfuric acid. And, just to mention, these solvents are commonly used to titrate weak bases. Finally, we have aprotic solvents. These are neutral solvents, meaning they neither donate nor accept protons. Some examples you might be familiar with are acetone, chloroform, and benzene. Aprotic solvents are mainly used to dissolve nonpolar substances. So let's talk about some common non-aqueous titrants, starting with perchloric acid, or HClO4. This is, the most widely used titrant in non-aqueous titrations. It's especially effective when we're dealing with weak bases. And, just to note, the usual solvent here is a combination of glacial acetic acid and acetic anhydride. Next up, we have sodium methoxide, or NaOCH3. This one is typically used for titrating weak acids. The solvent that goes along with sodium methoxide is methanol. Now, let's quickly look at the indicators used in non-aqueous titration. Crystal violet changes color from yellow to blue and is used for weak bases. Azoviolet also shifts from red to blue, again for weak bases. For weak acids, quinaldine red is the go-to, changing from red to green. And finally, auricate blue, which goes from violet to blue, is used for general purposes. So these indicators really help us see the endpoint in these titrations. Alright, let's walk through the procedure step by step. First, you need to prepare the sample solution in a suitable non-aqueous solvent, like glacial acetic acid, for example. Next, select the appropriate titrant. Perchloric acid is a common choice here. Then, add 2 to 3 drops of the indicator. After that, titrate slowly until the endpoint color appears. Once you see the color change, note the burette readings carefully. And finally, repeat the titration to obtain concordant values. That's pretty much the whole process. Now, let's talk about where this is actually used in pharmacy. This method is commonly used for the assay of weakly basic drugs, such as ephedrine, antihistamines, diphenhydramine, chlorpheniramine, atropine, and aminopyrine. It's also useful for weak acidic drugs, including benzoic acid, salicylic acid, and phenol. So, as you can see, it has quite a few important applications in pharmaceutical analysis. So, let's talk about the advantages. Non-aqueous titration is, really accurate for weak acids and bases. It gives sharp endpoints, which is super helpful. It's also suitable for water-insoluble drugs. And yeah, there's no interference from water reactions. But of course, there are some limitations too. Organic solvents used in this method may be toxic, and they can be quite expensive and flammable. You have to take more precautions, and sometimes the indicators may be unstable. Non-aqueous titration is a powerful method used in pharmaceutical quality control to accurately determine drugs that cannot be titrated in water. It gives sharp, reliable endpoints, making it essential for modern pharmaceutical analysis. Like, share और सब्सक्राइब करना ना भूलें DRX Learning Hub को. Thank you.